Hello people, I'm back with section B of this paper 2021 Science 2. Let's just check the code to make sure it is the one. 2021 Science 5124 paper 2, which is chemistry. Section B. 1. B1. The following diagram shows the changes of states in the three states of matter. So diagram: solid, liquid, gas, these arrows and the like. Describe the arrangement of particles in 1. Solid. Particles are tightly packed and vibrate in their fixed positions. Therefore, that's their arrangement. Okay, they are tightly packed and they somehow oscillate in their fixed positions. Liquid particles are loosely packed and held together by weaker forces. They slide over each other. They are packed in such a way that they're not really separate. They're still held together and have the ability to slide over each other. Therefore, this is the reason why liquids can flow, and any substance that can flow qualifies to be called a fluid. Fluids are substances that have the ability to flow. B. State the name of the change of state labeled A and B. That is evaporation and freezing. A is evaporation from liquid to gas. Then B is freezing or even solidification, therefore from liquid to solid. This one would have been desublimation or deposit, or this would have been sublimation, but from gas to solid would have said it would have been desublimation or deposition. The last question there to make our 6 marks. Which change of state, A or B, is exothermic? Explain your answer. Freezing is exothermic. Therefore, the substance or the system loses heat from the environment. Freezing occurs when you remove substance when you remove heat from a substance. Therefore, cooling is the removal of heat from a substance. So, freezing involves the substance losing its heat to the surrounding. Okay, that's our answer there. B2. The following is a list of methods used to separate mixtures: filtration, chromatography, crystallization, distillation, fractional distillation, evaporation. Choose from the list above the suitable method that would be used. To A. Obtain pure water from sodium chloride solution. Sodium chloride is common salt. It dissolves in water, so the only way you can get it out of its solution is by simple distillation or just distillation as it is put here. B. Separate method, a mixture of ethanol and water. These two are liquids, so they form a mixture or a solution, and they are miscible liquids. So the fact that they are miscible liquids meaning they can mix completely, so you can only separate them by fractional distillation, which involves the separation of miscible liquids based on their differences in their boiling points. C. Copper 2 sulfate crystals from saturated copper 2 sulfate solution. That's crystallization. Okay, crystallization. Number D. Obtain barium sulfate from a mixture of barium sulfate and sodium nitrate. Barium sulfate is insoluble, and sodium nitrate is all sodium salts are soluble, and so are nitrates. All nitrates are soluble. So by filtration, because barium sulfate is insoluble. E. Separate colored substances in a sample of a soft drink. That's chromatography. We have 5 marks, people. We have 5 marks. We get to B3. The following table shows structures of 4 particles, P, Q, R, and T. So the particles are there: protons, neutrons, and electrons. Number of protons, Which particle is a neutral atom? These two, okay, P and Q, because the number of protons and neutrons are the same, meaning they both don't have any charge on them. B. Which particle is a negative ion? State the charge. T is our negative ion, and the reason is because it has got more electrons than protons, so it has a surplus of 2 negatively charged particles, so its charge is going to be 2 minus, or negative 2, but it's 2 minus, so T is our anion. Which 2 particles are isotopes? Give a reason. That's P and Q. P and Q are isotopes because they have the same number of protons. Look at this, 11, 11. But they differ in the number of neutrons. So have the same number of protons but different number of neutrons. That's the answer over there. D, the last one. Use the periodic table to identify particle R, magnesium. You find that on magnesium the number of protons is 12. So when you check out on the periodic table, element number 12 is actually magnesium. So our answer there is magnesium. On the table there, the magnesium has got 12 protons. So you see, that's 12 protons. Therefore, it's element number 12 on the periodic table, magnesium. Before ethyl ethanoate can be prepared from ethanol and ethanoic acid. Ethanol is an alcohol, ethanoic acid is a carboxylic alcohol, acid or organic acid. Write the balanced chemical equation for the reaction. This is our ethanol and this is our ethanoic acid, and this is our ethyl ethanoate, and that's water. When they react, water is liberated. Yes, water is part of the product, so they are all in liquid form right there. So B, calculate the theoretical yield of ethyl ethanoate which can be obtained from my resolution not so good. Okay, yeah. 23 grams of ethanol. So I simply made or came up with ratios. Okay, so I've put my ethanol here, then my product there. I got, this is 46 grams of ethanol, 88 grams of ethyl ethanoate. Where did I get this from? From the balanced equation. The balanced equation always gives you the fixed ratios which can help you determine or find the theoretical quantities of the species involved. From ethanol, this one here, this is 1 mole, and this is also 1 mole, and even this one is 1 mole. So this, the mass or the molar mass of this is 46, 24 for carbon, 2 of them, 12 plus 12, 6 for hydrogen, then 16 for oxygen. I add them all, I'm getting these masses from the periodic table, 46. Then this here, you have carbon, 3 carbons, and each one has a mass of 12 as on the periodic table. Multiply that by 3 gives you that. Hydrogen, these are 3 plus 5 gives you 8. Then oxygen, there are 2 giving you 32. 88 is the mass or molar mass of ethyl ethanoate as in the equation here. So this is actually 46 grams reacts with this acid here, ethanoic acid, to give us this much, or 88 grams of ethyl ethanoate. So what would 23 grams produce? If 46 gives 88 grams, what would 23 grams give of ethanol? Of course, then cross multiply, find your x. My answer comes out as 44 grams of ethyl ethanoate would result, in theory, okay, if everything was to be perfect of the perfect. Otherwise, it's never really perfect because there are so many factors that tend to come into play, and as a result, yield is never 100% due to losses and reactants, changes in temperature, pressure, and all those factors that tend to affect rates of chemical reactions. So C, if 33 grams of ethyl ethanoate is produced from the 23, of course, calculate the percentage yield. So in theory, you would get this. Now, if you in practice you obtain 33 grams, what would be your percentage yield? So percentage yield is equal to actual yield over theoretical yield. So actual over theory times 100. Actual here is 33. Theory is what we were from doing. We divide that, multiply by 100, gives you 75% is our answer. 6 marks are all ours. And the last question there is just trying to help us, or maybe ask us, not help, but ask us of where, to which homologous series does ethyl ethanoate belong? It's an ester. It's an ester because it involves the reaction or the bonding of an alcohol and an acid, of course, organic acid. And the linkage between them is known as an ester linkage or ester bond. We'll get to the next question. B5, the pH scale is used to indicate how acidic or alkaline a solution is. Some numbers from the pH scale are given in the following list. Okay, what type of solution would have a pH of 1? A strong acidic solution, people. So below 7 represents acidic pH, above 7 represents alkaline pH. The lower you are in pH below 7, the stronger the acid. The higher you are in pH above 7, the stronger the basic properties of that given substance or solution. Let me just say solution. B, which pH value from the above list would be for lime water? That's 12. Lime water is calcium hydroxide. Calcium hydroxide is also known as lime water or slaked lime. Calcium hydroxide is known as slaked lime. Calcium oxide is known as lime. Then calcium carbonate is known as limestone. Calcium carbonate is limestone. Calcium oxide is lime. Then calcium hydroxide is slaked lime. although calcium oxide is also known as burnt lime. Okay, burnt lime. So B, which pH value from the above list would be for lime water? 12. Pure water, 7, is neutral. It has got same number or equal concentrations of protons and hydroxide ions. Then number 3, vinegar is a weak organic acid. It's actually a weak acid, that is 3. Number C, what would be the color of the solution with pH value 14 when tested with the universal indicator? Some books will tell you violet, which is actually purple, or dark blue. Okay, dark blue. So I was about to write, let me just maybe write it here. I was about to start writing the color changes of what happens in color changes in terms of when you're using universal indicator. So just 1 minute, let me just move my paper and then I write down the colors. Okay, so when you're using universal indicator and your solution is very acidic, this is what is going to be in terms of color. When the solution is a weak acid, it's going to be something like a pink or something like that. When the solution is neutral, you're going to get a green. Okay, when the solution is a weak base, you're going to get blue. And when the solution or your solution is a strong base, you're going to have purple or dark blue. So strong acid, weak acid, neutral solution, weak base, strong base or alkali. There's a difference between a base and alkali. All alkalis are bases, but not all bases are alkalis. Therefore, a water soluble base is what is known as an alkali. So hopefully we're able to remember that. It's very, very quite simple. Next question there, B6, are some reactions of metals VW, X, Y, and Z. Okay, X, Y, Z is back, are given in the following table. There they are. So arrange these metals according to their decreasing reactivity. I'll begin with W. Look at this: explosive reaction, followed by V, then steady fizzing Y, then no reaction, which is X. So X is our least reactive. Decreasing reactivity, therefore you start with the most. As we move, the reactivity is reducing. Be mindful of that. So next question there, B, which of these metals could be magnesium? Why? Magnesium doesn't easily react with cold water. It doesn't react with cold water because it forms a coating of magnesium hydroxide on its surface, which is almost water impermeable. It's like the behavior of zinc, which forms zinc hydroxide as well. It's like the behavior of aluminium as well. Okay, so magnesium tends to form this barrier, magnesium hydroxide, which is almost insoluble, and as a result its reactivity is very slow unless you increase the temperature. That's when the magnesium will show its reactivity. So magnesium is our thing here. Does not react with cold water. Hot metals react with steam. Hot metal meaning the metal reacts with steam. You have to heat it and heat the steam to simply force it to perform. Okay, our metal X there is copper. Put it in cold water, the guy will be quiet. Put it in hot water or steam, the guy will still be quiet. So see the equation for the reaction of W with cold water is given below, which is our most reactive metal behind there. Look at what it does to water. It forms a hydroxide and liberates a gas. What gas do you think that would be? Because oxygen has remained here, therefore one hydrogen has been removed. This is hydrogen. So describe the taste for the gas. Do not name the gas even if you know it. Just describe it. Keep the name to yourself unless you are asked to do so. Don't go like it's hydrogen. Look at the space here. So just describe its identity test. It puts off a burning splint with a small explosion. Some people go like a pop sound. Okay, yeah, a small explosion. It's the same thing. To which group of the periodic table does metal W belong to? That's group 1. If anything, this could be cesium, because among metals, the lower you go down the group, the more reactive the metals become. We have scored 6 marks, people. The following diagram shows 2 forms of carbon, P and Q. Okay, name the allotrope labeled P, that's diamond. Just look at the way it's connected. I call it diamond because each carbon atom is joined to 4 other carbon atoms, meaning the valency of carbon is completely used up. The bonding pair electrons are completely used up. Here, this is graphite. Each carbon atom is bonded only to 3, and it has got these layers. These dotted lines mean or represent or show to say this layer is actually supposed to be on top of the other layer. Explain the meaning of the term allotrope. It simply means different physical forms of an element. Therefore, atoms of the same element are joined differently, okay, existing in different forms due to their different physical forms, due to their different ways in which they are joined. Carbon, if anything, exists in three in form of three allotropes. There's diamond, graphite, and then there's also amorphous, meaning non-crystalline carbon, which is in the form of coal or the common charcoal that we use. So the difference between coal and charcoal is that the charcoal we use in our braziers, is porous, okay, because it comes from trees. But for coal, it is compressed because it's simply organic matter that underwent degradation in the absence of oxygen. So what type of bonding is represented by these forms of carbon? Covalent. Okay, covalent. If anything, carbon is said to be tetravalent, has a valency of 4. That is why each one here is 4. Here, each one is 3, meaning there is an extra electron which has not been involved in the bonding. As a result, they're asking which allotrope named in A has a physical property which is typical of metals. It's Q. Q is graphite. Because of the extra electron which is not involved in the bonding here, graphite is capable of conducting electricity, meaning there's one electron from each atom that is delocalized, that is free to move around. Remember, covalent bonding fixes electrons in bonds such that the electrons are not there are no free electrons that are left to be mobile in the structure. So number 2b2 there, set the physical property, that is electrical conductivity. Graphite is what pencils are made of. Okay, so it's a very good conductor of electricity. Let's go to our last question in this section. Okay, our last question in B, which is question 8. The structures shown in the are members of one of the homologous series in organic chemistry. OH, OH. These guys are alcohols, man. This is methanol, ethanol, propanol. If anything, this is 2-propanol because it's on carbon number 2. I'll give the general formula for this homologous series. Okay, I thought maybe this N was not going to be visible, but this is the general formula. I had actually forgotten it. I went to check somewhere where I have them, I have them in some bag. Yeah, so alkanes of their own alkenes, alcohols, esters, get to know them. That's the general formula for the alcohols. What is the functional group of the homologous series? Hydroxyl group, which is the OH group. S is used as a fuel because it burns in oxygen. Write a balanced chemical equation for this reaction. That is our balanced equation there. So if anything, don't balance the equation on the answer sheet. Try to balance it aside from this from your answer sheet, because you make your equation dirty. I was almost detaining it because when you're balancing, you just have to count 2 carbon, and then I put a 2 there to have 2 carbon. Hydrogen 6. This is 5, 6. I put a 3 there to have 6. Okay, then I have oxygen. This is this was 1, 2, 3. So on the other side, I had this is 4, then plus 3 gives you 7. So this goes back to 6. I put a 3 there to give me plus this one 7. So that's our balanced equation there. Complete combustion of ethanol. Our last of the last questions to mark the scoring of our 5th mark in this question is, which of the compounds RIST would have the highest boiling point? Understand that the bigger the molecule, the higher the density, the lower the volatility, the lower the ability to evaporate, the higher the boiling point, the more viscous, meaning the more thicker the liquid becomes. So understand those properties. So this one is likely to be also the least reactive because it's bigger. The more reactive, or the more this alcohol, 100 mils of this alcohol drunk at once can knock someone unconscious. This one need 200 mils, so this one is less reactive. So at the end of it all, this one is actually has the highest boiling point because of its size. This marks the end of section B for this paper 2021. This is paper 2, which is chemistry 2021 5124. I'll see you as I'll be looking at section C. Bye bye for now.